Hello students, today we are going to start a new topic, that is electrostatics of 12th class 1, most important topic of the 12th class. Basing on this one, we have a lot of questions will be asked in the competitive examinations, and one of the highly conceptually topic this is. How much time if you taken it is not sufficient, and if you understand this topic very well, you can solve the problems very easily, but it has to be very required practice, and numerical practice is required for this topic. So before that, we have to be very clear about the basic concepts of this topic. So first, what is electrostatics in this topic, what we are learning. Before that, how the secondary topics are arranged according to the certain concept we will discuss, and we'll enter into this topic. So first, come to the case of in the universe we have matter, right? That matter is contains three states: liquid states, solid state, and gaseous state, whatever may be state. So every liquid contains, okay, every state of matter contains atoms inside. Every state of matter contains atoms. This is the atoms, we can say. These atoms are highly packed in the case of solids, loosely packed in the case of liquids, heavily, okay, completely loose in the case of gases. Every atom contains, you know that if you take in the structure of any atom, you know that the atom contains the nucleus at the center, that is having positive charge we are calling, and around it electrons are revolving. So here this positive, whatever it is, nucleus we are calling, this is called charge of the atom, which is at the center positive, and the electron which is revolving also having charge, that is also revolving around the nucleus. Now in this case, our concept is the charge we are indicating with a small q. The charge of a, okay, any body we are indicating with charge, okay, small q. Basing on this small q, we are classifying the different topics. Condition of the charge q, we are explaining the topics here, like electrostatics, current electricity, and magnetic effect of current, and electromagnetic induction light. So what way we are arranging, that we will discuss in a short way, because that is required. One of the previous competitive examination, that question is asked, but it is not given of any individual topic. That's why starting only we need to understand. So first, if we come across the case of whenever you taken any charge inside the body, so we have a charges. There is a positive charge is there, negative charge is there. Every body contains positive and negative charges are there. So the charge which is there, we are indicating with a small q, a small amount of charge, initial charge we are calling as small q. If this charge inside the body, if it is not moving, that means if the velocity of the charge is equal to 0. Now using that concept, if the charge is exhibiting some properties like, means we have a lot of properties we can observe everyday life. So example, if you come across, you are using the printers every day, right? The printers are working, what way the letters are going to be printed on the page, that is one of the principle behind electrostatics. So principle behind electrostatics, and you may know certain examples in the previous classes you may learn. After taking comb and okay, so comb, after combing your hair, if you keep it on the piece of papers, it attracts the papers. That is also one of the electrostatic concept only. And whenever you are sitting on the chair, if you hit with a towel, you will get a shock. Small shock will be, you will observe that is also due to electrostatics only. And you may be observed in the outside, okay, videos are something, okay, something like when you taken the electrostatic sphere, charges sphere, when you hold it, what happens, your hair is going to be raised due to electrostatics. Why I'm discussing all this, because whenever the charge is not moving, whatever the examples I just said, that example where the charge is not moving, that effect we are explaining in terms of one of the concepts called electric field concept. Which concept? Electric field concept. It is one of the vector quantity. That electric field concept, whatever we are using to explain that topic, is comes into electrostatics. So electrostatics is one of the branch of science which deals with the okay, effect of the charged bodies when it is at rest. When the charge is at rest, whatever the effect the body is showing, that is called as electrostatics. In that case, that effect we are explaining using the concept of electric field. So when the charge is at rest, it is exhibiting only electric field. Some cases, the charge may be in motion. If the charge is moving with a constant velocity, the charge is moving with constant velocity. In this case, the charge is moving in the constant velocity means, if you take any conductor, inside the conductor, if the, okay, inside the conductor, if the electrons are moving inside the conductor. If the electrons are moving, these electrons, if the electrons are moving, we are saying that there is a current existing in the houses. So wires carrying the current, that is due to electron flow may be used there, right? So that electron flow is called as current. So here when the charge is moving with a constant speed, in that case it exhibiting some effect as a current around the current carrying wire. So that means charge moving wire. In that case, that effect we are explaining using two concepts. One is called electric field concept and also using magnetic field concept. Means current carrying wire producing electric field as well as magnetic field. Only when the charge is at rest, producing only electric field, there is no magnetic field. But when charge is moving with a constant speed, it is producing electric field as well as magnetic field both. Now, when charge is moving with variable velocity, not a constant velocity. Okay, variable velocity. Variable velocity means whenever the velocity is changing, what happens? That is, there is acceleration takes place. Acceleration is not equal to zero. In this case, what is the acceleration? Acceleration is equal to zero because velocity is constant. When acceleration is not zero, when electron or proton, whatever it is, the charges when they are moving inside, if the velocity is not constant, in that case, acceleration is not zero. That is, that charges are called accelerating charges were called. These accelerating charges exhibits the property by producing the electric field as well as magnetic field, along with there is a emission of energy that is called nothing but heat energy also generates. Example, like you are using the heaters, that heaters heats the coil. In that there is a electric field will be created, there is a magnetic field will be created, we can't see that, and at the same time heat is also going to be produced. So when the charge is moving with the variable velocity where acceleration is not zero, in that case it produces electric field, magnetic field as well as heat. So this topic, whatever it is we are learning first, when the velocity is zero, only electric field related topic, that is called electrostatics. Now second one, the only related to electric field as well as magnetic field relation, both linked relation, whatever we are learning, that is nothing but current electricity topic. If the velocity is not constant, there is electric field, magnetic field as well as heat. That we are calling as electromagnetic induction topic. Here this second one, when the charge is moving with a constant velocity, only in terms of charges, that is current electricity as well as combination of electric field and magnetic field is called as magnetic effect of current. So these are the topics. First one is electrostatics, second one is current electricity as well as magnetic effect of current, and this one is electromagnetic induction. Like that we have a relation. Why I am discussing this one? Every body contains the charges according to the condition of the charges. So they have some effect, the charges will have effect. According to that effect, we are explaining these topics like electrostatics, conduction, like that. Now in this, what we are learning in this topic, electrostatics. Electrostatics is the topic whenever you taken any body, when the charges are at rest, whatever the effect they are exhibiting, that is called as electrostatics. What the effect means? In the nature we have different forces. The charges, may exhibit the properties like attracting the other charges or repulsing the other charges. Example, like whenever you are using the comb, after the comb, if you keep it on the piece of paper, it attracts. What is happening here? It is attracting. What is attracting here? The charge is, one charge is attracting the other body's charge. That is called effect. That effect is at condition of rest of the charges, there is no transfer of charges, is called as electrostatics. When the charges are at rest, whatever the phenomena exhibited by the charges called as electrostatics. Now in this case, that effect you can see in the form of attraction, and you can see in the form of some like rising of your hand, attracting a piece of papers, and printing of the printers usage, like a lot of applications are there using electrostatics. Next, according to our basic, there are two types of charges we have. One is positive charge, second one is negative charge. Now according to charged body, if the only charge is there, means we cannot say that is charged one, right? So if you take in any body, the body I can say is a charged body. How we can say charged body? If we start attracting the other bodies or repulsing the other body, then I can say these charges are these charged body having charged condition. So here there are two types of mainly charged bodies are there. One is called positively charged body and second one is called negatively charged body. So other than this one, we can also able to explain one of the body called as neutral body. That means if the body contains okay more number of positive compared to negative, that body is called as positively charged body. The body which contains more number of negative compared to positive, that is called as negatively charged body. The body which contains equal number of positive and negative, this is nothing but called as neutral body. Okay, in the case of neutral body, now this body will not exhibit any property of attracting or repulsing the other bodies. But these are the two bodies which are positively charged body, negatively charged body exhibits the property of attracting the other body. So if any body acquiring the property of attraction or repulsing the other body when the charges are at rest is called as electrostatics. Now the statement of the electrostatics we can define like this: when a charge, okay, when the charges are at rest, the property of the body to attract or repulse other body is called as electrostatic. Means the body, if it is attracting or repulsing other body, the at rest condition is called as electrostatic. This is a statement we can use it for the examination purpose. Next one, we are going to discuss methods to charging a body. How many ways we can charge a body? We have three methods to charging a body, because every body you can see here, there are a lot of bodies we are using every day. All bodies will not attract the other bodies, right? That means they are not charged. If the body is said to be charged, means it is going to be attract or repulse. Either one of the property it exhibits. So if it is not showing, that means it is not charged body. So how we can make the body to be charged? There are three methods to make the body to be charged. First one called as conduction method. Second one is induction method. Third one is friction method. Conduction method. What we are doing in the conduction method? Conduction method is nothing but we are connecting one body to other body directly in contact. By contacting the one body to other body, we are transferring the charges, and using the concept of transferring charges, what happens? One body gets charged. That method is called as conduction method. I will explain detailedly next. What is induction method? Induction method is nothing but it is the method of charging one body without touching the other body. By keeping the one body near to the other body, we can make the other body to be charged. That method is called as induction method. Third one is called friction method. What is the meaning of friction method? By taking the comb, after combing, what is happens while you are combing, the brush is going to be, that means the comb is going to be, okay, under the friction with your hair. Due to that, what happens? There is a charges are going to be developed on the comb. That means the comb is going to be get charged. That's why what happens? It is able to attract the piece of papers which contains the charges. So if you want to make the body to be charged, you have to, okay, using the friction method also we can make the body to be charged. So now we are going to discuss the first concept of conduction method. What happens? How the charges are going to form. In the conduction method, I taken one positively charged rod, glass rod, that is positively charged one, and I taken a sphere which is neutral conducting sphere. Neutral means what? Positive charge means the body which contains more number of positive charges compared to electrons, that is called as positive charge body. This is positive charge. This is equal number of positive and negative is called as neutral body. So whenever we are touching this body to this one, contact, at the time of contact, what is happening? Before understanding this one, first you need to understand one of the point of concept, that is called potential. Potential means here, as per the phenomena of any, okay, flow of charges, the charges always flows from high potential to low potential. To remember this one, you keep it in mind always. Air flows from high pressure to low pressure. Water flows from high level to low level. Heat flows from high temperature region to low temperature. In the similar way, current flows from high potential to low potential. Current always flows from high to low. So here also, whenever you take any charged body, when it is connected to the neutral body, one body acts like a high potential, another body acts like a low potential. So this is positively charged one, it acts like a high potential one, and it acts like a low potential one. This you cannot decide exactly. Sometimes it may be high, it may be low. but according to my discussion, this is having more positive compared to neutral body I taken. According to this one, less. So whenever the high potential to low potential when you taken, what happens? Okay, always the charges will flow from high potential to low potential. Which charges? Positive charges. The positive charges will move from high potential to low potential, that is Q plus. At the same time, what happens? These electrons which are there, the negative electrons which are there, these electrons also, okay, moves from opposite direction of the charges. That means electron will flow. Always remember, high potential to low potential, the positive charges will move, and low potential to high potential, the negative charges will move. So here, whenever you taken the concept of charge flow, always we are taking one method of direction, that is positive charge direction. So positive charges will always move from high potential to low potential. Electrons will move from low potential to high potential we are taking, but generally we are taking the electron flow as the charge flow generally. So here, whenever the one body connected with another body, neutral body, what happens? After some time, both bodies will becomes positively charged. That means the rod is anyway it is positively charged one, so it contains the positive charges, and the sphere which is connected here, so the sphere which is connected here, that is also becomes into positive charges by transferring the electrons into this. It is not guaranteed, sometimes it may becomes negative also according to the type of charges. So in this case, both becomes positive charge. This method of transferring the charges from one body to other body and making the other body to be charged is called as method of conduction. So this is the one of the uncharged body we are making into charged body by contacting directly, is called as conduction method. Next one, induction method. What is induction method? Without any contact in the bodies, we can make the other body to be charged. It's called induction. You can look at the here. I taken one positively charged glass rod, and I taken one sphere of charge one. Sorry, neutral sphere. Neutral sphere means initially the charges are okay, positive and negative are lies inside. Now, whenever the glass rod is brought near to this sphere, neutral sphere, when you brought near, it is not contact. There is a gap. At that moment, what happens? You can see here, there is a negative charges are going to be developed at the near end of the rod, and you can see that opposite end positive charges are going to be developed. That means what is happens? The positive attracts the negative. That's why the negative charges will be accumulated near end of the positive rod, and the positive repels the positive. That's why what happened due to repulsion of this one, this all positive charges of the okay sphere will be accumulated on the other side of the sphere. Means in the case of induction process, whenever you brought the charged body near to the neutral body, near face you'll get the opposite charge, and the opposite face you'll get the similar charge. Here plus means here you got minus, opposite charge, and the other side you got similar charge plus, due to attraction repulsion phenomena. So that means here these ends are becoming negative. Now we are doing some process here. What we are doing? Negative. This side we are connecting to the ground. Second side, when you connect to the ground, ground means what we are calling as zero potential. Ground means zero potential. Zero potential means what? Okay, if you add the charges, if you remove the charges, will not alter anything for the earth. So that's why it is called ground, whose potential is always we are taking as zero. So in this case, what is happens when you connect this one, all positive will goes into the ground and negative will be accumulated onto the sphere. So whatever the positive we have, here these positive charges will be goes into the ground, and from the ground negative charges will be accumulated on that. So when the ground, okay, a thing is connected. Now what we are doing in the next step is remove the grounding. After doing this one, you remove the grounding. When you remove the grounding, what is happens already? The charges which are there on this one already went into the ground. So that means the okay charges on the sphere only left is negative charges. That means the sphere contains only negative charges. There is no positive charges which are present before. Before there is a positive charges. Now there is no positive charges here. Now finally the sphere, the neutral sphere becomes into negatively charged body. This is called as induced charges. That means the body which becomes into induced charged body. So by bringing the one body near to the other body, we can make the other body to be charged, is called as induction method. In this process also we have a lot of questions theoretical, and some problems also going to be discussed. We'll discuss in the coming. In the method of friction, You can look at one of the example I taken here, glass rod and silk cloth. Whenever the glass rod and silk cloth are neutral initially, when you rub glass rod with the silk, what is happens? The glass rod acts like a positively charged one. You can see the indication of the charges here. It acts like a positively charged one. It acts like a positively charged, and the silk cloth will gains the negative charge, negatively charged. How we can able to explain that? We can able to explain using the experimental method. Now look at the experiment. I taken one glass rod, positive charge one. I taken silk cloth. After rubbing, after friction method, it got positive and negative charges. Now similarly, I taken two positive rods. I taken two negative charged silk cloths, and if you are doing the suspend the rod and using another rod, if you keep it near, what happens? The rod positive rod will be deflect away from this actual rod. That means positive repulse. That's why due to the repulsion, what is happened? The suspended rod will be moving away from that. If you have a still doubt, you can come across a case of cloths. I taken two charged cloths are there. We don't know that positive or negative. Whenever you are keeping near to these two, what happens? Both are going to move away from each other. So two bodies are moving away from each other, nothing but repulse each other, means that is due to single charges only, because you know that like charges repulse, unlike charges attracts. That is one of the concept we can explain using the method of friction. Using the method of friction, we can make the body to be charged, and that can be verified using experimental. Next concept is quantization of charge. What this quantization of charge explains? Consider two bodies, both are positively charged. So in this case, which is more positively charged, which is less positively charged? By looking at the diagram, we can, but we can't see inside the body how many charges are present. So the calculation of the charges which are acquired by the body at static condition, we can explain using the quantization of the charge concept. The quantization of the charge concept explains that whenever the bodies get charged, each charge is going to be get the property of attracting the other body or repulsing the other body. Now when that condition, the body is said to be charged body, so at that moment it contains either only positive charge or negative charge condition. So here I taken positive charged body, so it contains a lot of positive charges. So how many all positive charges are present? That gives the total charge of the body. So that calculation of the total charge of the body we are indicating with a capital Q, called as quantization of charge method. We are doing this one. What is the quantization of charge is stating is the total charge of any body is equal to integral multiples of, that means plus or minus n, integral multiples of number of electrons present in that body. Number of electrons present in that body means number of charges present in that body. We can take number of electrons present in that body, because electrons can be able to calculate according to the electron configuration. That's why the quantization of the charge is explained based on Q is equal to plus or minus Ne, where N is called integral number of electrons present in that body. So here the more positive, less positive also we are explaining based on electrons only, and more negative, less negative also we are explaining based on electrons only. The body which contains more number of electrons called less positive. The body which contains less number of electrons called as more positive. So based on this one, the quantization of the charge explains that it is the integral multiples of number of electrons present in the charge. What is this E electron? Electron is one of the charge. The charge of that electron is equal to, value is equal to how much? 1.6 into 10 power minus 19 coulombs. This is verified using millicon's oil drop experiment. So whatever the n number, that n number is equal to, it may be that is 1, 2, 3, so on only. This n value never be fraction, that is like 1 by 2, 3 by 2, 5 by 2, so on like this, 5 by 2, so on. It is not possible. So the number of electrons never be fraction value, it may be multiples times of charge of the electron. That is called quantization of charge. So statement we can say very simply, what is quantization of charge? The quantization of the charge is a method of calculating the charge of a complete body in terms of number of electrons present in that. That is called as quantization, can be defined as it is a integral multiples of number of electrons present in that body is called as quantization of charge. Now we can go for next, how many number of electrons present in 1 coulomb of charge, like that, and we can go for next procedure. The most important point is the number of electrons which are present in the body must be in terms of integral number only, 1, 2, 3, so on only, not in the fraction. Fractional charges cannot be possible inside the body. In the quantization formula, Q is equal to number of electrons present in that is in terms of positive and negative, that is integral multiples of number of electrons, plus or minus, right? This Q we are measuring in terms of units coulombs. This is the basic unit coulombs. Also we can write in terms of stat coulombs also. We have a lot of relations, okay, in the measurement of this charge. So mainly we are measuring in terms of coulombs, microcoulomb, okay, like that. So in this case, coulombs is the unit of this charge. So here I am taking one of the concept here. Example, 1 coulomb. That means the body is charged by 1 coulomb. So when it is charged by 1 coulomb, how many number of electrons are present? How many electrons? How many electrons are present in that 1 coulomb of charge? To explain that one, you take the quantization of the charge value, Q is equal to ME. So in this case, what is Q? Nothing but 1 coulomb. So you are taking as 1 is equal to N into E. So they are asking number, how many electrons? How many means? That is number they are asking. N is equal to 1 by E. That is 1 by electron charge value 1.6 into 10 power minus 19. That is fixed value always. This value if you calculate, that is we are going to get 6.625 into 10 power 19 we are going to get. This value you are not going to get. Okay, this value, if you calculate this value, how much you are going to get, that is you are going to get 6.25 into 10 power of 18 number of electrons you are going to get. Means 1 coulomb of charge contains 6.25 into 10 power of 18 number of electrons which are present. Now we'll do one example problem. A glass rod is rubbed with a silk cloth. The glass rod acquires the charge of plus 19.2 into 10 power minus 19 coulombs. They're asking 3 questions here. First, find the number of electrons lost by the glass rod. Find the negative charge acquired by the silk. And is there any transfer of mass from the glass to silk? So first, we have to understand that when glass rod is rubbed with the silk, glass rod acquires the charge 19.2, means the glass rod acquires, when the body will acquire the positive charge, when the electrons is transferred to one body to other body, now electrons becomes less and it becomes more positive. So here, so we need to calculate the find the number of electrons lost by the glass. Who is lost by the glass? Glass rod is losing, because that's why it is getting positive charge. So the number of electron which is lost by the rod we can calculate using quantization of the charge, Q is equal to N. So number of electrons we need to calculate, N is equal to Q by E. So how much charge is there? 19.2. This is the acquired charge. The corresponding number we need to find. That is 19.2 into 10 power minus 19 coulombs by charge of the electron. What is the charge of the electron? What is the charge of the electron? The charge of the electron is 1.6 into 10 power minus 19. Anyway, this is get cancelled. 19.2 by 1.6 value nearly, that is you get 12 if you calculate. So number of electrons which are transferred is equal to how many? 12 electrons are transferred. We can see the number of electrons lost by glass rod is 12. Find the negative charge acquired by the silk. How much positive charge acquired by the rod, that much equal and opposite negative charge will be acquired by the silk. So the silk will acquire the charge of minus 19.2 into 10 power minus 19 coulombs charge it acquires. What charge it lost? The charge it acquired. Rod is lost by 19.2. Okay, that means 12 electrons it is lost. The corresponding charge it acquires by the silk, equal and opposite. Next, last question, is there any transfer of mass from glass to silk? Okay, if you come across a case of there is a transfer of electrons taking place. According to the concept electron having mass, what is the mass? Okay, what is the mass of the electron? Mass of the electron is 9.1 into 10 power minus 31 kg. So whenever the electrons are transferred from one body to other body, there is a mass transfer takes place, but that mass is very, very small compared to the size of the mass body. That's why we are not generally discussed. But as per the charge concept, when the charge is, when the electrons are transferred, mass is also changes. So which gains more electrons that have more mass? Less electron, less mass. Means I can say here the positively charged body, negatively charged body, both are having same mass. In that case, this is m plus, this is m minus. So in this case, the m plus always less than m minus, means the negatively charged body mass is always more than positively charged body mass. How much mass is okay? Mass of the, what is the transfer of mass from glass to silver? How much mass? 12 electrons are transferred. So 12 electron transfer means 12 electrons mass. What is the mass of each electron? That is 12 into 9.1 into 10 power minus 31 you take. So this value, how much? That is the answer for question in this. After solving this one, 1.08 into 10 power, we are going to get minus 29. This is the mass of the electron. This minus also very small. That's why compared to the two masses, we are not much finding the difference. So this is the quantization of charge concept and how to do the problem based on this one.